right, ladies and gentlemen, today we're going to talk about literal equations, dimensional analysis, and weighted averages. We're going to wrap up chapter 2 today. So we have one new skill that we're adding on today. We're going to talk about rearranging formulas to highlight a quantity of interest using the same reasoning as in solving equations. So we're going to be rearranging formulas to find the piece that we want to look at. We're going to continue working on REI 1 and REI 3, where we're solving linear equations and showing our work in multi-step. And to do that, today we're going to model with mathematics. So today we're going to be using lots of real-life examples, things that you will encounter that use these math skills. So first, our three vocab terms today are the three big ideas. The first one is a literal equation. Well, a literal equation is just another word for a formula. It's an equation that involves several variables. And one thing to remember, and this is especially important on one of the homework problems, is that if we have the same letter, but it's lowercase compared to a capital, it's different. A lowercase a is a different variable than a capital A. Next, we have dimensional analysis. Dimensional analysis is also called unit analysis, and this is an essential skill in science. It's the process of carrying units throughout a computation to make sure that you end up with the type of units that you want. Last vocab term is a weighted average. And so a weighted average is a calculation that considers the varying degrees of importance of the numbers in a data set. So a true average, we just take all of the values and divide by the number of pieces, but a weighted average takes into account the weight, the importance of different values. So first, let's practice with this one here. I have my equation 7x minus 2z equals 4 minus xy. Well, now the first thing I want to do when I'm looking at this problem is I want to get all of my x on the same side because I'm looking to find x. So I want to take this this xy and I want to add it to both sides. Now when I add it to the left side of the equation, there are no like terms. I don't have any other terms that have a coefficient and then xy. So I have 7x plus, I'm just going to write it next to it here, because my commutative property of addition tells me it doesn't matter where it goes, minus 2z equals 4. Well, now I want to get rid of everything that doesn't have an x in it, so I'm going to get rid of that 2z by adding it to both sides. And I'm left with 7x plus xy equals 4 plus 2z. Now when I'm looking at this here, I want to think about how I can get x by itself. Right now I see that it's tied up both with my 7 and with my y. So what I need to do is I need to factor out that x. X times 7 plus x times y. Well, that's the same thing as pulling out x times 7 plus y. We're undoing the distributive property here. We're factoring out x from each of those terms. Now when I see this, my last step to get x all by itself, I'm just going to divide both sides by 7 plus y. I'm going to keep that together as one unit. That grouping symbol tells me that those pieces are moving together. And I get my final answer. Let's change colors again today. I write it up at the top here so I have space. X equals, I'm going to leave this as that fraction here. I have 4 plus 2z over 7 plus y. There's nothing else I can simplify here. I'm going to leave it alone, put a box around it. My final answer is x equals this big mess. These two equations are equivalent. If I take a look at this thing that I started with and this that I'm ending with, I have not done anything to change the solution set, so my values are still equivalent, just rearranged. So that's a literal equation. So now let's practice with some dimensional analysis. And in this one here, I want to calculate the average weight of a chimpanzee in pounds if I know that they have an average weight of 52 kilograms. I know there's many ways to address this problem here, but we're going to practice with dimensional analysis. So what that means is I want to work through my units and conversions so that everything cancels out. I'm going to start with 52 kilograms. And I know that I want to end up with something in pounds. So the first place that I'm going to convert is I see 1 kilogram is equivalent to 1,000 grams. Well, anytime I multiply by a value of 1, my answer stays the same. So 1 kilogram over 1,000 grams equals 1, and 1,000 grams over 1 kilogram equals 1. I'm going to write my fraction like this because just like I know if I have variable on the top and bottom, kilograms will cancel with kilograms. So now if I type in 52 times 1,000, I get 52,000 grams is equivalent to 52 kilograms. But I want to keep going with my unit analysis here. Now I want to convert grams into ounces. That's my next conversion factor that I'm given. So again, I'm going to write my fraction. I know that I'm going to want the grams on the bottom because I have grams in my numerator on the last step. So I have 1 gram is equivalent to 0.0353 ounces. And I'm going to squish it. We'll erase some stuff here. I'm going to squish my last conversion in here. I have ounces into pounds. My grams have canceled out now. So now my final answer would be in ounces. My last step, I'm going to take those ounces and turn them into pounds, maybe if my pen works. There we go. To do that, I want ounces on the bottom so that it cancels out, and I have 1 pound on the top. So my giant setup looks like this here, and I'm going to take my values, and I'll start with kilograms, and I end up with pounds. So when I simplify my fraction here, I'm left with 52 times 1,000 times 0.053 in my numerator. And if I type that in on my calculator, I get 1,835.6 over 1 times 1 times 1 times 16 pounds. Well, in this case here, I want to type that into a calculator and simplify my fraction down to a decimal. And I find out that 52 kilograms is equivalent to 114.725 pounds. And now let's do our reasonableness check. We know that a kilogram is about 2.5 pounds. So if I take 52 times a little bit more than 2, do I land somewhere above 100? Yes, it passes the reasonableness test. If you were solving this out here and you had your numbers in the wrong spots and you didn't divide by 16 and you found a value of 1,835 pounds, well, that wouldn't pass the reasonableness test because we have a basic idea of how many kilograms to pounds. And we can check our work by typing in on an online conversion calculator 52 kilograms to pounds, and we should get a value of about 115 pounds. So now let's try a weighted average. A weighted average problem here, well, this is a real world example. What I have here is a student's GPA is calculated based on the student's grade and their credit rating for the class. Using the report card shown, calculate the GPA. So this one here, I pulled some classes out of Carol's catalog for classes. And in college, different classes have different ratings. High school, most classes are worth either 1 credit or half a credit. But in college, you'll have some classes that have a lab portion that'll be worth 4 credits. You'll have some worth 3, 2, 1. Credits tell you basically the amount of work required for the class. But this one here, I see a math class with 4 credits, a chem class with 4 credits, history with 3, PE for 1, and a jazz band class here. These are all classes that I took at Carroll, but these are not my grades. I gave you samples here so that we could work with it. To find the weighted average, I need to know how many grade points we have divided by the total number of credits attempted. So what I'm going to do, I know that an A is worth 4, a B is worth 3, a C is worth 2, a D is worth 1, and an F is worth 0, but I don't have any examples of those. So I'm going to change my values here. So instead of B, I'm going to put a 3. For A, I'll put a 4, C is a 2, B is a 3, and A is a 4. So to find my weighted average, I'm going to take each piece and multiply it by its weight. So that first one, for math class, I get 4 times 3, so that one has a weight of 12 grade points. My chem class, I have 16 grade points, 4 times 4. For Civ, I have 3 times 2. For PE, I get 1 times 3. And for jazz, I get 1 times 4. So those would be my total grade points divided by the number of credits attempted. So 4 plus 4 is 8, plus 3 is 11, 12, 13. Divided by 13 total attempted points. So when I type that in, I get 3.15 as a grade point. And again, let's think about reasonableness. This is the GPA for this theoretical class here. Let's see if that passes the reasonableness test. If I look at my classes, it looks like I have A's, B's, and C's, but it looks like we're pretty much a B student, and that matches. A B is equivalent to a 3, so we're just above a 3.0. Last weighted average problem is another one that you may encounter when you take chemistry in high school. The atomic mass of an element is the weighted average of the atomic masses of the naturally occurring isotopes of that element based on the percent abundance of each isotope. So the example that I have here is chlorine, which has 2 naturally occurring isotopes. Chlorine 35, so a mass of 35, is 76-ish% abundant, and chlorine 37, so chlorine with a mass number of 37, has about 25% abundance. So I need to calculate the average atomic mass in atomic mass units. Well, when I think about this, the first thing I want to do is that reasonableness test. If I know that chlorine 35 and 37 are my 2 isotopes, I know that my weighted average is going to fall somewhere between those 2 numbers. But in this case here, I can see that 75% is that chlorine 35 and only 25 is that 37. So my true average would be a 36, but I know that it's going to lean closer to that 35. So I'm going to think in my head that this should be about 35.5, somewhere between 35 and 36. So when I calculate this, I'm going to multiply each mass by its percent abundance. So I have 35. Well, when I'm turning percent into a decimal, I move over 2 spaces. So 35 times 0.07577 plus 37 times its percent abundance, 0.2423. And when I multiply 35 times its percent abundance, I get 26.5195. 37 times its abundance gives me 8.9651. When I add those together, I get 35.4846. And I'm dealing with atomic mass units, so I'm putting my units on there. About 35.5, it passes that reasonableness check. So now your job is the homework task listed here, number 9, from page 143. So again, we're continuing with that end of chapter review, and it's a relatively short assignment here, only 71 through 80. I want to point out that number 79 and number 80 especially, is pretty challenging, so make sure that you're thinking hard. I'll have the key posted on Teams, and you can self-grade and submit your scores. This is our last homework assignment for chapters 1 and 2, so make sure you get this done. Next week, we are going to work on some Delta Math, and we're going to do a practice test review. If you are a B group student, you'll be taking the test on Friday. If you're an A group student, you'll be taking it on Monday. And DLI, you'll take it on Friday. Thanks, guys. Keep up the good work.